Hello, my name is Jeremy Rigneris, and welcome to the Choose SOLIDWORKS Screencast series. When evaluating 3D CAD applications, it's only natural to focus on part design and drawing creation. However, many of the proven benefits of 3D are realized at the assembly level, where fit and function of an entire system can be tested and costly problems can be identified and resolved. But before you can check for interferences, clearances, or correct mechanism behavior, you have to assemble the components together in the first place. Components are held together with relationships, or mates as they're called in SOLIDWORKS. The simplest way to understand how mates work is if you were to describe how two parts fit together. For example, in this transmission model from Baker Drivetrain, these two fascias should be coincident. First off, SOLIDWORKS has made an intelligent guess as to what sort of mating condition you need. You then continue to add mates until the component is fixed, and you can see how quick and easy this process is. To make this process even faster, you can use Smart Mates. Holding down the Alt key whilst dragging a component will automatically add the correct mate type, which you can of course change if you want. Smart Mates can be added to library parts so that reusing them in your assembly is fast and the mates are added automatically. This is a real time saver, especially when adding fasteners from SOLIDWORKS Toolbox. The fasteners from Toolbox snap into place and resize themselves accordingly. Bolts and screws can be resized in length using the Instant 3D on-screen ruler to select the next available size. The Copy with Mates command makes light work of duplicating one or more components to other locations in the assembly. And if they share a common reference, this can be reused, making it even faster. If a fastener is added to a hole that is part of a pattern, the rest of the holes can be automatically populated. This is fast, but more importantly, if the number of holes should change, the number of fasteners will automatically change as well, so your assembly is always up to date. The countershaft needs a number of gears and retaining rings assembled to it, so let's use some other, even faster mating techniques at our disposal. Picking an edge whilst using Smart Mate adds two mates simultaneously, concentric and coincident. To add the gears onto the shaft, you need to make them all concentric. To reduce the number of mouse clicks, SOLIDWORKS has a multi-mate option, where one single common reference can be reused any number of times, and the mates can be also grouped into one single feature, making them easy to edit and easy to organize. To position the gears between the thrust washers, you need to add a coincident mate to each one. The Select Other tool allows you to pick hidden geometry when mating faces or edges, so there's no need to rotate the assembly to add the mate. So far, we've only used the standard mates, but it gives you a good idea of how easy they are to use. For more complex assembly mechanisms like this one, you can use advanced mechanical mates to complete the job. Assembling the drum onto the bearing allows it to rotate and translate along the bearing axis. But since the pillow blocks are not symmetrical, there's no center plane to align the drum to. One of the advanced mates, called the Width Mate, provides the best solution. The drum is aligned perfectly between the two pillow blocks and is now only free to rotate. The spring-loaded arm is a cam, so you can use the cam mate to make a cam and follower pair using straightforward selections. A cam mate will allow surfaces to have multiple contact points, but this is not always desirable, so a warning message lets you know there could be a potential problem with your design. Now, when you move the drum, you can see the range of motion of the cam at the same time as well. SOLIDWORKS has mechanical mates that convert rotary motion to rotation or translation, enabling you to simulate regular gears, bevel gears, and worm gears, or even rack and pinion and screw drives. Selecting a circular edge or sketch defines the gear ratio. So ideally, these gears should have a pitch circle sketch, but this can be easily overridden to get precise meshing of the gears. Sometimes the screen can get a bit too busy when you've got a lot of components in your assembly, making it more difficult to see what's going on. The easiest way around this is to use the Isolate command. This hides all the other components so you can concentrate on the task at hand. Now, to place the fork in the groove on the gear, you could use the Width Mate or a simple coincident mate. Continuing with the design, the fork should run along the slots in the drum. The path mate enables a point to move along a predefined path. The point can be free to move, or fixed at a certain distance, or a percentage along the path, with full control over the pitch, yaw, and roll of the component. This can be used for anything from cams and slots like this to simulating the path taken by components along a conveyor system. All of these mates added to the assembly can be reused directly in animations or motion simulations, so you only ever need to set up your assembly once, and there's your complex gearbox. Thank you for taking this quick tour of some of the powerful assembly mates in SOLIDWORKS. We strive to deliver simple but effective tools to help you focus on creating fantastic designs, not fighting with the CAD tools, and to make it an enjoyable experience too. For more information and to see other screencasts in this series, please explore the SOLIDWORKS website or contact your local SOLIDWORKS reseller. My name is Jeremy Regnerus. Thank you for watching.